Kia ora koutou. This video is for Gabe in Ottawa, who has sent me some questions that are chain rule practice. Now, Gabe only wants me to worry about questions C and E in here, but I want, if my A-level class are watching this, you might want to have a go at the other ones for some practice as well. I'm going to do the answers to them at the end. So C, I think, is a pretty straightforward one once you remember how to differentiate exponentials. E is a chain rule, but it's a kind of double chain rule. So I'm going to look at those ones first. And if you're in my class, the one that's probably making you hesitate is this one here, which I will go through after I've done the two green ones. So I've just done a whole video on this, and I'm so tired that I hit delete instead of upload, so I'm just going to start this all again. So the first question for Gabe is this one here. I've got y is equal to, what have I got? E to the 3x plus e to the negative 3x over 2. And the first thing we want to notice is that that looks way worse than it is, because all it is 1/2 of e to the 3x plus 1/2 of e to the negative 3x. Now we know that the exponential function differentiates to give me the exponential function. So here I've got a little chain rule question where I've got dy by dx is equal to 1/2 of e to the power of the thing, right? So e to the 3x times the derivative of the thing, the derivative of the inside function. And then I do the same thing on this one, and I've got plus 1/2 e to the power of the inside function, negative 3x, times negative 3. So my derivative is 3 over 2 e to the 3x minus 3 over 2 e to the negative 3x. That gets a big tick from me. A slightly nicer way to write it would be this, but it really depends on what you want to do with it from there. Okay, so that's that one done. So the next question you wanted me to look at was this one here, where I've got a sine cubed thing. So I think it's worth looking at a kind of year 9 form, I don't know what you call it in Canada, but over here, year 9, first year of high school, picture of a function. So the function here is a bit mucky. It's y equals sine cubed of x squared. I think that's what it was. Yep. Right, so we start off with our little x, and we think about what happens to it. So the first thing that happens to it is that x gets squared, and then it has sine of that number taken. So it becomes sine of x squared, and then that number is getting cubed. So when we do the chain rule, we've got two inside functions. We've got the innermost function, which is the x squared, and then the kind of middle layer of past the parcel function, which is the sine, and then lastly we've got the cubing, right? So this is just a polynomial, but a polynomial of a sine x squared. So when I do the chain rule, I have to make sure I've got all of those derivatives, because the change in x is going to flow through each of those functions. So dy by dx is going to be, first of all, it'll be 3 sine squared of x squared, right? So that's differentiating the outer function. And then I have to multiply it by the derivative of the trig function. The derivative of sine is cos, so it's going to be times cos of the inside function, the x squared. Lastly, I have to differentiate my innermost function, which is 2x. So that gives me my final answer of 6x sine squared x squared times cos of x squared. Now I just want to look at question B as well, and this is really in case there's anyone in my class watching, not just Gabe in Ottawa. Now, by the way, guys, I do know Gabe in Ottawa. He's not just some rando from the internet who sent me a bunch of questions. Okay, so this last one, I've got this. I've got y equals 3 to the x squared plus 2x. Now, it's really hard to differentiate 3 to the power of something, but it's easy if I translate it into an exponential. So we can rewrite this as y equals e to the natural log of 3 to the x squared plus 2x. Now, how do I differentiate that? Well, if I use my log rules, I can clean this up quite a bit. The log of a to the power of b is equal to b times the log of a. So y is equal to e to the power of x squared plus 2x natural log of 3. If I want to differentiate that, my outside function is the exponential one, and my inside function is this. So I've got e to the power of all of this, because e to the power of something differentiates to e to the power of something, times the derivative of the inside function, times, so it's going to be the natural log of 3 times 2x plus the natural log of 3 times 2. So cleaning all of that up is easy. I can rewrite this as 3 to the power of x squared plus 2x, and then this is just going to be times 2 log of 3 into x plus 1 if I'm fully factorising. Probably worth putting that in brackets as well. So there you go. I'm not going to bother with the other ones. Thank you for watching, guys. This time I'm going to try and upload the video instead of deleting it, and just send in any questions that you want videoed over the next few days.